Good morning. In this session, I'm going to continue with motion in a straight line. So, yesterday I have completed distance displacement concept. Today, let us start with speed. Okay, then we go to velocity. If there is time, we go for average velocity and so on. So, let us start with speed. See here, speed is defined as rate of distance traveled. Rate means per unit time. So, speed is equal to distance by time. So, is it a scalar or a vector? You just guess. As a distance is a scalar, speed is definitely a scalar. It has only magnitude but no direction. So, speed is a scalar. And now, coming to the CGS unit of speed. For distance, CGS unit is centimeter, per time it is second. So, CGS unit of speed is centimeter per second. And MKS unit of speed is meter per second. Now, let us see different types of speed. Instantaneous speed. Instantaneous speed. For the word instantaneous, you can guess what it is. The speed of a body at a particular instant of time. See here, suppose if you are moving in a car. Suppose if you want to know the speed of the car at that particular time, instant, then where do you look at? Yes, you look at the speedometer. So, speedometer reading gives instantaneous speed. Speedometer reading gives instantaneous speed. Okay, speedometer reading gives instantaneous speed. And the next is uniform speed. Uniform means constant speed. Speed of a body is said to be constant if it travels equal distances in equal time intervals. Suppose speed of a body at a particular instant is 5 meters per second. If it is constant, it should move with the same speed, that is 5 meters per second, throughout its journey. Okay, so it has to travel that 5 meter distance in that 1 second time interval. So, if a body travels equal distances in equal time intervals, then the speed is said to be uniform. Equal distances. Equal distances in equal time intervals. See here, next let us see non-uniform speed. Non-uniform speed. This is uniform speed. Non-uniform speed. Non-uniform means variable speed. Variable speed. So, speed is variable if it travels unequal distances. Unequal distances in equal time intervals or vice versa. Unequal distances in equal time intervals or equal distances in unequal time intervals, then the speed of the body is said to be non-uniform. Okay, and next let us see what is average speed. Average speed. Average speed is total distance by total time. And average speed depends on the path taken. Average speed depends on the path taken because the distance depends on the path taken. So, look here, coming to the definition for speed, the rate of change of distance with respect to time. Or speed is distance by time. It's a scalar quantity. It has only magnitude but no direction. Instantaneous speed. Speed of a body at a particular instant and it is measured by a speedometer. uniform speed. Here the body has equal distances covered in equal intervals of time. Non-uniform speed, unequal distances in equal time intervals or equal distances in unequal time intervals. Average speed is total distance by total time. Average speed depends on the path taken by the body. Next, let us move on to velocity. In the same line, we go for velocity. Normally, we represent velocity with V bar. Look here. Velocity is called, the first point, rate of displacement. Rate of displacement is called velocity. Rate of displacement. Velocity is equal to displacement by time. Velocity is a vector because displacement is a vector. And its CGS unit is centimeter per second. Displacement unit is centimeter, time unit is second. Similarly, MKS unit is meter per second. And instantaneous velocity. Instantaneous velocity. Velocity of a body at a particular instant of time is called instantaneous velocity. Speedometer cannot give instantaneous velocity. It gives instantaneous speed because if you look at the speedometer, you can find the magnitude of velocity only. But direction you cannot say from the speedometer reading. So, instantaneous velocity means velocity at a particular instant of time. Mathematically, it is represented like this. Limit delta t tends to 0, delta s by delta t. That is the mathematical representation of instantaneous velocity. The time interval is so small, it is almost tends to 0 but not equal to 0. So, in that particular very short time interval, the displacement by time interval is called instantaneous velocity. And now you can see just as before, uniform or constant velocity. Uniform or constant velocity. See here, from this definition, you can say velocity is displacement by time. So, uniform velocity means here the body has equal displacements in equal time intervals. So, uniform velocity means the body has equal displacements in equal time intervals. Equal displacements in equal intervals of time. Non-uniform velocity or variable velocity. From the definition, you can say equal displacements in unequal time intervals or unequal displacements in equal time intervals. That is non-uniform velocity. Unequal displacement in equal time intervals or vice versa. Average velocity. What is average velocity? You just tell me what is average velocity. Average velocity is total displacement by total time. As the displacement is independent of the path, average velocity is independent of the path taken by the body. That is just about the theoretical concept of speed and velocity. Here, if you go to the application, we can do so many things, and especially on average speed and average velocity, there are so many problems in JEE Main as well as in the NEET. So, let us concentrate on average speed and average velocity. Look here. So, let us go to average velocity. Look here. Average velocity is equal to total displacement by total time. That's all the formula is. See, I'll tell you only one model problem. You must be able to do any problem given on average velocity based on this simple concept. Look here. A body moves 5 meters east, then 10 meters north, and then 15 meters west in 10 seconds. Find its average velocity. So, from the data, a body moves 5 meters east, then 10 meters north, 15 meters west in 10 seconds. Find its average velocity. So, here I told you yesterday, this is east, this is west, this is north, this is south. For our convenience, this is represented as I bar, this is represented as I bar, this is minus I bar, north is J bar, south is minus J bar. See here, S1, it is 5 meters east, 5 I bar. S2, 10 meters north, 10 north is J bar. S3, 15 meters west, west is minus I bar. And the total time taken T is equal to 10 seconds. So, total displacement is S1 bar plus S2 bar plus S3 bar. This is 5I plus 10J minus 15I. This is minus 5I plus 10J is the displacement vector. Right? And we know that is the displacement vector. We know how to find out the magnitude. Magnitude of the displacement is square root of 5 square plus 10 square. If you take that 5 as common factor, 1 square plus 2 square, this is 5 root 5 meters. So, average velocity magnitude is displacement magnitude by time. This is root 5 by 2 meter per second. That is the magnitude of average velocity in the problem given. Now, velocity being a vector, we must know how to find out its magnitude as well as the direction. So, magnitude is root 5 by 2 meter per second and direction. Look here, I am writing it once again. This one, I am representing it on this diagram. This is I minus I j minus j. Minus 5I plus 10j lies in the second quadrant. Minus I plus 10. So, x component is 5 and y component is 10. So, this is alpha. So, we from that tan alpha is equal to opposite side by adjacent side implies alpha is equal to tan inverse 2. This is north of, this is west and this is north. Tan inverse 2 west of, north of, look here. It is tan inverse 2 north of west. That is the answer. So, for this, as per the data given, the answer is, it is root 5 by 2. V average is equal to root 5 by 2 meter per second at an angle tan inverse to north of west. That is the complete problem. Very common question in all these very common model in all these competitive examination. So, the concept is average velocity is total displacement by total time. So from the given data, you have to find out the net displacement. So total displacement by total time gives us average velocity. Okay. Next, let us move on to average speed. Look here. Average speed. Average speed is equal to total distance by total time. This is the concept. If you have this in your mind, you must be able to do any problem. So we just write it as V is equal to S by T, where V is the speed and S is the distance, T is the time. Now, the first model I am telling. A body covers distances S1, S2, S3, so on in respective times T1, T2, T3, so on. A body covers distances S1, S2, S3, so on in respective times T1, T2, T3, so on. Then average speed. V average is equal to total distance S1 plus S2 plus S3, so on, divided by total time T1 plus T2 plus T3, so on. That is total distance by total time. That is the average speed. Okay. Now, let us move on to the next concept. A body travels distances S1, S2, S3, so on with respective speeds V1, V2, V3, so on. See, follow that very carefully. A body travels distances S1, S2, S3, so on with respect to speeds V1, V2, V3, so on. Meaning it travels a distance S1 with a speed V1, S2 with a speed V2, S3 with a speed V3, and so on. Then just from that, average speed is equal to total distance S1 plus S2 plus S3, so on. The formula we know is total time, but here time is not given straight away. If a body travels a distance S1 with a speed V1, from this, what is time? It is S1 by V1. From this, if a body travels a distance S with a speed V, time taken is S by V. So from that, T1 is S1 by V1 plus T2 is S2 by V2 plus T3 is S3 by V3, and so on. That's it. So the next thing is, if a body travels distances S1, S2, S3, so on with speeds V1, V2, V3, so on, then the average speed is S1 plus S2 plus S3, so on by S1 by V1 plus S2 by V2 plus S3 by V3. Next, can you guess the question what I am going to ask you? See here, third one is, a body travels with speeds V1, V2, V3, so on in respective times T1, T2, T3, so on. Look here. Here we know only one formula, that is total distance by total time. Right? Here the problem is time is given, so total time T1 plus T2 plus T3 plus T4 and so on. That is perfect. And distance. What is the distance S1? It travelled with a speed V1 for time T1. So what is the distance covered by the body in the time interval T1? So again from this expression, distance is equal to speed into time. So S1 is equal to V1 into T1. S2 is equal to V2 into T2. S3 is equal to V3 into T3, so on. So average speed is equal to V1 T1 plus V2 T2 plus V3 T3, so on, by T1 plus T2 plus T3, so on. So this is how we do the problems based on average speed and average velocity. So there can be so many changes, but this is the concept. This has to be like a print in your brain. So the only concept is average speed is equal to total distance by total time. So S1 plus S2 plus S3, so on, by T1 plus T2 plus T3, so on. If T's are not given, S1 plus S2 plus S3, so on, by S1 by V1 plus S2 by V2 plus S3 by V3, and so on. If distances are not given, V1 T1 plus V2 T2 plus V3 T3, so on, by T1 plus T2 plus T3, so on. Actually, the concept is the most important thing. All these formulae, they must be in mind so that you can do the problems with speed as well as accuracy. Okay, if you get the formula straight away, you can do the calculation part carefully, then you can arrive at the accurate answer in the exam, right? Now, look here. I am giving you two examples. You have to tell me the final answer. So, follow the question carefully. If you want to pass the screen at any while learning, pass it, learn the question carefully, solve it, only then follow my explanation while learning. So, the first example is a body covers half the distance with a speed V1 and the remaining half the distance with a speed V2. Find its average speed. That is the question. Read the question. A body covers half the distance. Most important word is distance here. Half the distance with a speed V1 and the remaining half the distance with a speed V2. What is the average speed? So, if you want to solve by yourself, pass the screen there, solve the problem. Then you start the video, you can see my explanation as well. Look here. Now I am giving you the solution. Average speed is equal to total distance by total time, T1 plus T2. See here, half the distance. If the total distance is 1, the total distance is half plus half, and T1 is equal to S1 by V1. T2 is equal to S2 by V2. S1 is half V1. S2 is half V2. So, this becomes, look here, 1 plus half, 1 by, if you take that half as a common factor, LCM is V1, V2. So, here V2 plus V1. If you take that to the numerator, you will be getting average speed in this case is 2V1 V2 by V1 plus V2. So, if a body travels half the distance with a speed V1 and the remaining half the distance with a speed V2, average speed is 2V1 V2 by V1 plus V2. This is example 1. Let me go to another example. Look here, example 2. A body covers half the time with a speed V1, remaining half the time travels with a speed v2. Find its average speed. Did you write the question properly? A body travels half the time with a speed v1, remaining half the time with a speed v2. Find its average speed. So here, look, I am coming for the solution. See here, V average is equal to total distance by total time. So here, let us take total time as 1. Half the distance with speed V1. See, S1 is equal to V1 T1. S2 is equal to V2 T2. So, V1 time is half. V2 time is half divided by 1 implies average speed is equal to V1 plus V2 by 2. Do you understand the beauty in these two examples? If a body travels half the distance with V1, remaining half the distance with V2, average speed is 2V1 V2 by V1 plus V2. In the next example, if a body travels half the time with V1, remaining half the time with V2, average speed is V1 plus V2 by 2. So, they are the key words, half the distance. While reading the problem, the distance has to be circled or underlined. Okay, here half the time. Okay, we'll go to numerical examples based on this question. Look here, note down the question. A body travels half distance with a speed 30 km/h and the remaining distance with 60 km/h. Find its average speed. Find its average speed. That is the question. Solve the problem. Tell me the answer. Okay. See here. If you really remember the formula for this, the solution becomes so simple. Half the distance, the remaining distance is also half the distance. Half is done, so the remaining is half. So, if a body covers half the distance with V1, remaining half with V2, just now we proved average speed is equal to 2V1 V2 by V1 plus V2. If you just substitute that here, you will be getting 2 into 30 into 60 divided by 30 plus 60. This is 2 into 30 into 60. 30 plus 60 is 90. 3 times 20. This is equal to 40. So, the answer is average speed in this question is 40 km/h. Is that okay? So, a body travelled half the distance with 30 km/h, remaining half with 60 km/h. What is the average speed? It is 40 km/h. Okay. Now, look here. I am going to give you another problem. Note down the problem. A body travels half the time with a speed 30 km/h and the remaining time with a speed 60 km/h. Find its average speed. Find its average speed. That is the question. If you remember the formula which we already proved, then the answer will be like this. Half the time with V1, remaining half with V2. Then what is the formula for the average speed? If you listen the previous class perfectly, you can answer me straight away the formula. It is V1 plus V2 by 2. It is 30 plus 60 by 2. It is 90 by 2. Implies, in this case, average speed is 45 km/h. How interesting the question is. Do you understand? Here, if it traveled half the time with 30, half the time with 60, look, half the distance with 30, half the distance with 60, average velocity is 40 km/h. Right? And now, look here, half the time, then average is 45 km/h, because the difference is in the formulae. Is it okay? So, last problem for today's class on average speed and average velocity. So, with this problem, you must be able to do any problem given on average speed and average velocity. Note down the problem carefully. A body travels 30 kilometers for half an hour. 30 kilometers for half an hour. 60 kilometers with a speed 60 km/h. 60 km/h. And for the next half an hour, it travels with a speed 45 kilometers per hour. For the next half an hour, it travels with a speed 45 kilometers per hour. Find its average speed. Find its average speed. Just concentrate on the question. Look here. Remember, the strategy of solving physics question paper is, it is always better to go to the concept if you have any doubt in the problem. Suppose if you feel this as a new question, just go back to the concept. What is our concept here? Average speed is always equal to total distance by total time. Here he talked about three cases. So, S1 plus S2 plus S3 by T1 plus T2 plus T3. Now, look here. 30 kilometers for half an hour. S1 is 30, T1 is half an hour. Very good. Now, 60 kilometers. S2 is given with a speed is 60 km/h, but we want T2 here. So, from the expression V is equal to S by T, T is equal to S by V, implies T2 is equal to S2 by V2, that is equal to 1 hour. So, T2 is given as 1 hour indirectly. Now, coming to the data. Next half hour, T3 is given with a speed 45. So, S3 is missing. But from the same expression, S is equal to Vt or S3 is equal to V3 T3 implies S3 is equal to V3 is 45 km/h and time is half an hour. Okay, half an hour. So, here now S1 30, S2 60, S3 45 by 2, that is 22.5 kilometers. Okay, I am substituting those values here. S1 is 30, S2 is 60 and S3 is 22.5 divided by T1. T1 is half an hour. T2 is 1 hour. And T3 is half an hour. So this is 90 plus 22.5. 90 plus 22.5. 112.5 divided by half plus 1 plus 1. It is 1. Not 1. It is 1 plus 1. It is 2. Okay. 112.5 by 2. 5 2s are 10. 12. 6 2s are 12.25. So, average speed is equal to 56.25 kilometers per hour. 56.25 kilometers per hour, that is the answer. So, here in this question our main concentration is on the formula. Average speed is total distance by total time. S1 plus S2 plus S3 by T1 plus T2 plus T3. So, from the data given, we try to find out S1, S2, S3, T1, T2, T3. On substitution, we got the answer. Okay. So, this is the synopsis part of average speed, average velocity. We'll be doing more number of problems in the objective session. Today, I'm going to close this session. In next session, I'll continue with acceleration, then equations of motion. Okay. Thank you and bye-bye.